Okay, good morning. So we learned about trigonometric equations last time. There are some points that I haven't covered. I think it might be a little bit confusing. So let me talk about those as well. Okay. So, for example, I see some exercises in the book that they ask you to solve this trigonometric equation in a given interval. I don't think that's hard, but let me just give you an example so that we can solve this together. So, for example, I would say find all solutions to the equation sine 3. So that was right, 2 sine 3x equals to 1. On the interval, find all solutions to the equation in the interval say x between minus 90 degrees up to say 500 degrees. So there are some problems if you see in the book. They ask you to solve the equation, but an interval is given to you. You are supposed to find all solutions in that interval, not all possible solutions. Yes? Okay, but of course, the first part of it, if you want to solve that, you just need to solve it as usual. Yes? You need to find a formula for generating all solutions and then try to fine-tune those solutions in a way that the answers lie in this interval. Okay, but the first step is as before. So you just ignore this momentarily and start solving your equation. So you have 2 sine 3x equals to 1. What will be the first step? To divide by 2. So it becomes sine 3x is equal to 1/2. And then do you remember you can take this as a box, and then we had this formula sine of a box is equal to a number if and only if 2 things happen. Either number 1, the box is equal to sine inverse of that number k plus n times 360 degrees, or option 2 is that the box is equal to 180. For sine, if you remember, it was 180 minus sine inverse of k plus n times 360 degrees and belongs to z. This is something that we learned before for sine, yes? We had something similar for cosine and another one for tangent, yes? Okay, so if I want to solve that problem, so I will give the role of the box to this 3x. So then I have 2 options. So let me write 1. So the box, which is 3x, is equal to sine inverse of 1/2 plus n times 360 degrees. And then sine inverse of 1/2 is 30 degrees. So this is a famous number. So you have the table, so you can read the numbers. So it is 30 degrees plus n times 360 degrees. I am looking for x, so I have to make it alone. I divide everything by 3. Oops, it becomes 10 plus 120, yes? So x becomes 10 degrees plus n times 120 degrees, and n is an integer. Okay, so this is one possible solution. But of course, how many solutions I get? I get infinitely many, one for one choice of n from the set of integers. Okay, so we can solve the other one as well. So number 2, what happens that the second time the box, which is again 3x, is equal to 180 degrees minus sine inverse of 1/2, and then plus n times 360 degrees. But we just learned that this is 30 degrees, so if I subtract them, it becomes 180 minus 30, it becomes 150 degrees, and then I divide everything by 3, so what happens? X becomes 50 degrees plus n times 120 degrees. And also n belongs to C. Okay. So this is up to here. But now the rest of it is asking you find all solutions in this interval. Yes? So I have to fine tune the values of n so that it guarantees me that this answer lies somewhere here. Okay, I don't think that's hard. For example, n is an integer, so you need to consider negative values, 0, and positive values, the whole number. So let us start with -1. Do you think -1 will work? If I put -1 here, it becomes minus 120 plus 10, it's minus 110. Minus 110 is smaller than minus 90 degrees. So it is not in that interval. So if minus 1 does not work, I will not have any hope to find an answer if I go down. Yes, if I go to -2, -3, I am making it more and more negative. So of course it becomes smaller and smaller. So n minus 1 does not work. So, and then nothing before -1 will work. So let us start with 0. Does 0 work? Yes, because if I put 0, so you put n equals to 0, one answer that you get is x equals to 10 degrees. Okay? And 10 degrees is really between minus 90 and 500. That's it. And then how many numbers I can go up? So let us choose 1. Do you think 1 will work? Yes, because this becomes 120, and then plus 10 is 130. If I put n equals to 2, it still works, yes? Because it becomes 240 plus 10, 250. Yes, and if I put n equals to 3, it will work again. X becomes what? 370 degrees. And 4 will also work, and that is the last one which works, yes? So n equals to 4, it gives me what? 480 plus 10, 490. And then hopefully you agree with me, if I increase it, it will go beyond 500, and this is not acceptable. So this is a formula. In general, it generates infinitely many solutions, but because of this last constraint, I have only these solutions coming out of it. For example, in the national exam, they can ask you the questions like this. How many solutions does this equation have on this interval? So you need to do this, count them, and see how many solutions are there. But of course, it is not finished because we have also another alternative. Yes, we have also to check that one. So the same thing you did for this, you have to do with this one and probably find different answers, and then in total you count them. So in principle, you see that this is not a big deal. The whole point is to learn how to solve this equation, and then you can find it yourself. Okay, so let us just do this one here. Here, if I put -1, does it work? Yes. Yes, -1 works. So -2 does not work because -2 gives you -240 plus 50. It's -190, which is below that one. So -2 does not work, but -1 works. So if I start from here, for the second one, so let me write, this is for the first one, and then let me write here for the second one. So the first number that works is -1. So if I put -1, what happens? This becomes -120 plus 50 is -70, so which is acceptable. And then if I put n equals to 2, sorry, the next one is 0, x gives me 50. Yes? And if I put n equals to 1, x gives me 170. If I give 2, x gives me 290. and 3x gives me what? 410. Do you think 4 will work? No, it goes beyond. So if I ask you how many solutions are there for this equation on that interval, 1, 2, 3, 4, 5 from here, 1, 2, 3, 4, 5 from here. So I have 10 solutions for this equation on that interval. Yes. So I hope that this is not a problem. So you see that solving the problem, finding the formulas are important. The rest of it is just a normal calculation. Any questions? Okay. So this is one thing I wanted to mention. That's also good to see how we can solve equations with GeoGebra, because I told you it's important to know this. If you want to start an equation, solve an equation, any kind of equation in X, you will start with the word solve with capital L, and it probably suggests you this solve, so solve equation. And then you have to type your equation in, okay? So this becomes 2, and then I have sine 3x equals to, I don't know why it's undefined, equals to, what was that one? So you see, this is not complete. So GeoGebra in this view, it gives you only 2 answers. Of course, these are correct answers. Did we get them? Yes. One of them was 10, one of them 50. So it is in my list, but it is not complete. So if you start solving a trigonometric equation using this view, it will give you 2 main angles only. Okay, but if you want to solve them completely, so you need to switch the view. So you go here, no, not here, here. So you see here view, you choose that one, and then CAS, I think it is called computer algebraic system. So CAS is an abbreviation for that, so you need to choose this one. Okay, and then because I don't need graphics right now, let me take it off so that it is not disturbing me. So remember these things. And then you go here, and let me just do the same thing. Let us see what happens. Solve. So I go to solve, and I want to solve. I have more options here. Okay, it is algebraic system, so it solves more exactly. So let me type the same equation. So 2 sine 3x, and then I have equals to 1. And then I press enter. Okay, so it gives you a little bit weird of notations. The reason that you see like this is because GeoGebra by default works in radian mode. Okay, we haven't learned radian mode. The next lesson will be radian. And of course, sooner or later, you have to get used to new units of measuring angles. But if I remember right, if you want to solve the same problem in degrees, what you need to do, you need to tell GeoGebra that I want x to be expressed in degrees, and then you go here, before entering, you just go to functions here, and then there is a degree sign up there, okay? So you choose that one, and hopefully this will work this time. So you are telling GeoGebra that I want to measure my angle in degrees, not in your default mode, which is radian. And then you press this as an enter. And then you see that it is the same answers that more or less we got here. So you see it is 120 K1. K1 is the number instead of n. So K1 is an integer, okay? Plus 10. And because you yourself told it to be in degrees, so this should be expressed in degrees. And if you see here, 10 degrees plus n times 120 degrees is exactly this solution that you see here. Yes. And then the next one is 50 plus 120 times an integer k1, which is exactly the other solution. So remember, I really recommend you, because this is an old edition of the book we are using. Every now and then, instead of looking at the faucet to check your answer is correct or not, try to solve some of them using GeoGebra, so that you learn how to do it, okay? Because you might forget about this. Any questions here? Yes?
You use the interval to get all the answers for x.
You can check, by the way. I don't know everything in GeoGebra, but that's a good question. Next time I will also look at it. Okay, so might be there is, of course, I know that you can use graphical tool and see that which angles are there. Yes.
In GeoGebra, we can use it in your tests. Or is that what?
No, mainly the reason that I am bringing it up so much is because you have to know it for the national exam. In the national exam, they design some questions that you have to use an application to solve them. You cannot solve them analytically. Even I cannot solve them because the questions are designed in that way. So you have to have a digital tool. So it's extremely important to get familiar with the environment and the app so that you can use it easily. Okay? But of course, in our test, we can also use it because in exam.net, you can give access to students to use this without being able to use other parts. Yeah, so it's possible. So I mean, for the time being, please try to learn that. It is extremely important. So whenever you are doing some exercises in the book, do some of them with GeoGebra so that you can learn what is going on. Okay, any questions so far? So we learned if you want only two angles, this is not wrong, this is correct. But of course it gives you two main angles, yes? It's 10 degrees and 15 degrees. 50 degrees. But in principle, the CAS view is a better way to solve more precise, to find precise answers to your questions. Any questions so far? No? Okay. So now yes?
Is it there a setting to get all the answers that you got manually?
Manually?
What? You know the 10 different answers that you got? 10 different angles.
So you mean instead of doing it by one? Might be there is, because that's an application, so you know that you need to Google it and then find your tools. But I will also do that, I don't remember. But I know that you can ask GeoGebra to draw a graph within an interval. So in principle, if it can draw it within an interval, might be there is a way to find that one as well. Might be you can solve inequalities and find those things. So I will try to think about. I haven't thought about that before, but might be there is. Okay, but the standard one I want you to learn. Okay, and please do some exercises in the book using GeoGebra. Otherwise, it will be a big problem for you if you want to learn this on the exam. Okay, so now what we want to do is solve some more problems, and then we are done. Okay, so something I want to solve those problems. Let me see. Okay, so for example, let us solve this equation. So example, so let me write, solve the following equations. Okay, so what we have to do, so let me write number one. Sine 2x is equal to cosine x. So there is no new lesson here. So you need to, so if you want to solve a trigonometric equation, you need to reduce it into three standard forms. One of these three standard forms. Sine equals to a number or equality of two sines. Cosine equals to a number or equality of two cosines. Tangent equal to a number or equality of two tangents. We already have the formulas for these cases. But of course here you see that I have sine 2x on one side and cosine x on the other side. So this is not in principle, it is not standard yet. So you have to change it to a standard form, okay? And there is only one thing, you have to practice to see what you can do here. Any guess? Yes?
Can't we write cosine x as cosine 180, sine 180 minus x?
No, not sine 180 minus x, yes?
Sine
90 minus x, yes? Yes, that's correct, the complementary angle. So what you do, so you keep sine 2x as it is, And then what you do, instead of cosine x, you write sine of its complement. Complement. Complement of this angle is 90 degrees minus. Yes. Okay, now is it the standard? The answer is yes, because I have sine on one side, sine on the other side. So what can I write? I can say whatever here is 2x is equal to whatever here plus n times 360 degrees. Okay, or, so let me write this number one. So I get two options. Option number one. So what was the other option? Do you remember? I have equality of two signs. So the next one is 2x is equal to 180 degrees minus this. But be careful. You have to write it in pair of brackets, or if you do it in your head, remember to multiply minus sign by both of them, yes? So it becomes plus n times 360 degrees. Yes? So then what happens? This is just a normal equation. Let us do it in our head, yes? I move this to the other side, it becomes 3x. Then I want to isolate x, I divide everything by 3. Yes, so what will be the answer? This will be divided by 3. This also will be divided by 3. And belongs to z. Yes, that's an answer. And then this one, what happens here? So let me write it once more. I open up the pair of brackets, plus minus 90 degrees plus x, and then plus n times 360 degrees. Yes? But I'm looking for x. I move this x to the left, 2x minus x simply becomes x. 180 minus 90 is just 90, plus n times 360 degrees. And n belongs to z. Yes, is that clear? Let us test this GeoGebra here once more. Okay, so if I want to solve that one using this, so I type solve. I do this, and I type my equation, which is sine of 2x equals to cosine x. Okay, but of course, if you want to solve it in degree mode, so you have to type it like this, and the same thing here. And then you press enter. So you see that, so the numbers are a little bit different, very strange one. Did I do it correctly? Or might be, I don't know why GeoGebra provides these answers. So one answer is the same answer that I got. The other answer is 360 degrees. This plus 450 degrees. Okay, but I hope that you understand that what I have done is better than what GeoGebra has done. But the answer of GeoGebra and the answer of me are matching. Yes, do you see that? Yes? Because the first answer is exactly what I got. The second answer, instead of having 90 degrees there, GeoGebra provides 450 degrees. But I want you to see that the answer in GeoGebra matches exactly with my answer. Is that clear? Why? Why is that? Yes?
Because it took
Yeah, GeoGebra has written
0.
450 degrees plus n times 360 degrees, okay? But 450 degrees can be viewed as a 90 degree plus 360 degrees, yes? And then plus n times 360 degrees. So you can factor a 3, this is algebraic way of seeing it, yes? And then you can call this one, for example, k in GeoGebra, and then you get the answer. But geometrically, the final point of this angle and the final point of 90 degrees are the same point, yes? So where is 440? Where is 450? if you rotate one full round, it becomes 360 degrees. If you go 90 degrees more, it becomes 450 degrees, which is exactly at the same point of 90 degrees. Yes? So you see that sometimes the answers are not exactly what you get, but this doesn't mean that you have done it wrong. This also happens in the faucet in your book. So you have to have a good understanding of what is going on. Okay, so there are some problems. Let me choose. We cannot solve all of these equations you see right here. Let me go to number 2. Okay, so let us go to number 2. I want to write it here. Okay, so number 2. So what do you think now? I have minus cosine 2x equals to sine x. So this is another one that we want to solve. So how do you think I will solve this one now? Yes?
You know where you did the example up there?
Yes?
Where did the 2x go? Where did 2 go?
No, this I moved x to the right, to the left, 2x minus x becomes x. Yes, because I want to find x, yes? Okay. So how should we solve this now? There is a negative sign here as well. Yes?
You move it to the other side so it becomes positive.
What is the benefit? Let us say that we did it.
And then you do the same thing as the last time. You make it the complement.
No, but if you move it to the other side, 0 will be left here. And then I will have sine x plus cosine x. Then if I move the other way around, minus sign will go. I cannot get rid of the minus sign in this way. Moving things around takes minus sign from one side and put it the other side. Yes? Isn't it understanding? So what you're saying that move it to the other side. It becomes sine x plus cosine 2x equals to 0. Then what?
But if you do the same thing as last time, would the 0 be a problem or?
Yes. I don't understand because we have to have one sine or one cosine or one tangent equals to 0. I don't understand what you say. Let me just do what you say. You say sine x plus cosine 2x equals to 0. Then what?
You make either cosine or sine.
Okay, for example, I make it cosine of 90 degrees minus x equals to, no, plus cosine 2x equals to 0. Then you have to move it to the other side again. So the two cosines become equal, but there's a minus sign. So the point is that, so some of it is correct, of course. You want to change sine to cosine, cosine to sine. But even if you succeed to do that, there is a minus sign left. I should have equality of two sines, two cosines, or two tangents exactly, not even with an extra minus sign. So what you said solves this problem. Yes? Exactly like before. This is the reason that I'm bringing another example. I wanted to know what we're supposed to do with this minus sign. Yes?
You make the cosine into sine of 90 minus 2x. And then because minus sine of an angle is equal to sine of minus that angle.
Yes, so we combine these two, yes? The complementary angle idea together with this formula that if I have sine of minus theta is equal to sine, so it is equal to minus sine theta, yes? This is one way to look at the problems. Let us just solve this in two different ways. Okay, so this is good. So what you say, for example, I multiply everything by minus sign first. Yes? So it becomes minus sine x. Yes? And then using that formula, I move this minus sign in. So it becomes cosine 2x equals to sine minus x. Okay? Now, this problem is similar to the previous problem. Yes, I have one sine of an angle and cosine of another angle equal. Now, what you said is working now. So I have to use the complementary angle theory. Yes. So it doesn't matter if you want to change cosine to sine or sine to cosine. I don't know which one you prefer. So let us, for example, keep cosine this time. I change sine to cosine. So how should I do that? I need to write cosine of the complement of minus x. What is the complement of minus x?
90 plus x.
90 plus x. Why? Because if I ask you what is the sum of this angle and that angle, the answer becomes 90 degrees. So minus x and 90 plus x are complementary angles. So sine of one of them is equal to the cosine of the other. Okay? Now, but I have equality of two cosines now. So do you remember what was the formula? So if I have two cosines equal, so then the one on the left is plus or minus the one on the right. So this is either you have to think every time or you have to have it in your memory, okay? And then plus n times 360. Yes? Is that understandable? So this one of them couldn't work. So be careful. So you cannot say that the formula works for cosine and sine, so it also works if I have cosine and minus sign. You have to do something with the minus sign. Yes. I think you don't understand what's going on. Do you understand what's going on? Yes.
The sine minus theta, the formula we wrote out there,
Yeah.
is that also applicable to cosine?
No. These are, I told you that what is the difference between sine? Sine and tangent follows that rule, but cosine eliminates the negative sign. Yes? So cosine of minus theta. So this is what I told you. I mentioned this a lot. So if you don't have them in your memory, you will be a little bit in trouble. I don't know how you want to manage it. Okay. So for cosine, minus sign is gone. So that's what I'm saying, that in trigonometry, so the formula sheet will not help you that much because, for example, this is not there. The formulas that I'm writing are not there. So you have to have a very good understanding to be able to do it quickly, or you have somehow to have it in your memory. For tangent, what was the formula? Is minus tangent theta. Yes? Okay, then we have to solve that problem. Then I have two problems. One problem with positive sign, one problem with negative sign. So one problem with positive sign is just writing it as it is. And then I move x to the other side, it becomes x equals to that, yes? Okay, n belongs to z. So this is one solution. And the other solution, I take the negative sign, yes? So what happens? 2x equals to minus sign, but minus sign goes inside, so it becomes minus 90 minus x. And then plus n times 360 degrees. Okay, let us do this part in our head. So I move minus x to the other side, it becomes 3x. But because I want to find x, I divide everything by 3. So x becomes minus 30 plus n times 120 degrees. N belongs to z. Okay, so let me write this method 1. I don't know. You will learn if you solve the same problem in different ways. So one way was to use this formula and change sine to cosine. Okay? One other way is to use the same formula, but instead of changing sine to cosine, you change cosine to sine. Yes?
Is it possible for the second equation to write x is equal to 330 degrees plus n times 120?
This one?
Yeah.
No. Because this is a multiple of 120. Yes, not a multiple of 300. So you can add, for example, if you don't want to have a negative value here, you have to add 120 to it. Yes? So then it becomes 90 degrees plus n times again 120 degrees. Of course, so what you are saying in principle, if you have minus 30 degrees plus n times 120 degrees, what you can do, you can write it as this one, you can write it as 90 degrees minus 120 degrees, and then plus n times 300, n times 120 degrees. And between these two, you can factor a 120 degrees out. From this one, n is left. From this one, minus 1 is left. Yes? And then you can call this a new variable k. Because if n is an integer, n minus 1 is also an integer, so you can call it different. So there is no difference between this way of writing and writing 90 degrees plus k. So this number that sits here is important, yes? So if you have this number 360 degrees, it means that you can add or subtract integer multiples of 360 degrees. But here you have to add or subtract integer multiples of 120 degrees. Okay, so here you see method 1. I used this idea and I used changing, writing sine as a cosine using complementary angle theorem. Okay. You can do the same idea, but instead of changing sine to cosine, you can keep sine and change cosine to sine. Yes? That is also possible. Another way is also possible. I want you to do the other one yourself, and then might be you get different answers from here. Convince yourself that the answers that you get are equivalent with the answers that we have here. But do you remember another method? So method number 2, I don't want to use this. I want to use something else. So what can I do? Do you remember? Instead of minus cosine 2x, I cannot use this formula because this formula does not allow me to move minus sign in. Yes, that's a little bit unfortunate. So what can I do? I can, instead of cosine 2x, I don't know how much you remember, you can write cosine of what? You can write cosine of 180 degrees minus x, minus 2x. So do you remember we talked about supplementary angles? Cosine of 180 degrees minus 2x, 180 degrees minus 2x is supplement to 2x. And the cosine of supplementary angles are opposite. So for example, this is also probably should work. So you write, instead of minus cosine 2x, you write that. And instead of sine x, you write cosine of 90 degrees minus x because your goal is to make them cosine and cosine, for example. It should give you the final same answer. Let us check. So what you see here, 180 degrees minus 2x is equal to plus or minus 90 degrees minus x plus n times 360 degrees. Okay, so what you have to do, you have to consider two cases, the plus sign, the minus sign. If I consider the plus sign, it becomes this. Okay, so I move this to the other side, it becomes minus x. I move 180 to the other side, it becomes minus 90, and then plus n times 360 degrees. And because I want to find x, I divide everything by -1 or multiply by -1. It becomes positive 90 degrees minus n times 360 degrees. Yes? So this is the answer that I will get. I don't know, can you see this answer and that answer are the same? Why? Because the names are different. Because if n is an integer, minus n is also an integer. So you can call minus n to be a new n. Okay, so for example, this is equivalent to saying that this is 90 degrees plus, let me call it m times 360 degrees, m belongs to z. It doesn't mean that m and n are equal, but it means that the set of angles generated by this formula will be the same as the set of angles generated by that formula. Okay, but for example, if you give 1 here, you generate 450. to generate 450 from this, you have to assign minus 1 to n. But eventually you will get the same set of angles. Okay, so this is important to see that this answer is not contradictory with that answer. They're actually equivalent. Okay, and the other one is number 2. So what I do, the left-hand side is 180 degrees minus 2x is equal to, I choose the negative sign goes in, it becomes minus 90 degrees. This becomes plus x, and then I have n times 360 degrees. Okay, so I move this to the other side, it becomes minus 3x. I move this to the other side, it becomes minus 270 plus n times 360 degrees. Yes. Now I divide everything by minus 3, so x becomes positive 90 degrees minus n times 120 degrees. And I hope that you, according to what I said, by the way, are these answers the same now or not? Yes, is that understandable? They are the same because, so if you choose this method, you don't need to convince yourself that this answer is equivalent to that. But if you are solving the same problem in 2 different ways, this is important to understand why the answers we get are the same. So this answer is enough. You can stop here. If you are certain about what you have done so far, you don't need even to check it out. But I want you to understand that these 2 answers are now equivalent. Why? Because, for example, instead of 90, I can write minus 30 plus 120. And then I have minus n times 120, yes? So then I would write minus 30. I can factor 120 out. So it is 1 minus n times 120. And then you see that 1 minus n also covers the full range of integers if I choose n to be an integer. So I can call it m, and this becomes the same answer as before. So you have to be a little bit dynamic in thinking about trigonometric equations, yes? So this trick is very important, change sign to cosine or cosine to sine, and the trick of the negative sign, which one you want to use, that's also important. Okay, so let me solve another problem. Okay, there is a problem in the book, I haven't talked about that before, so let me also solve it here. So what about this equation? So which number is this? This is number 3, yes? So number 3, this is an equation in the book. They have even solved the equation in the book. But let us review this. Sine x not equal to cosine x equals to square root of 3 cosine x. Now we want to solve this equation. So what do you think we can do here? Yes? Yes? So what we can do here? Yes?
Divide by cosine x.
Yeah, so this is the solution to this one. So you see that the previous trick will not work here. So even if I change cosine to sine, the left-hand side will be sine. The right-hand side is not just sine, it is a multiple of sine. If you want to use the formulas so far, we have to have equality of exactly 2 sines or 2 cosines or 2 tangents. Okay, so square root of 3 will prevent us to do that. So the trick for this problem, so you need to learn. So we divide everything by cosine. You might say, how do you know that? No, I didn't know that before, but I learned that after solving problems. That is the logic, okay? So if you want to do this, we divide by cosine x. So you might say why, you have to be patient to see why this method works and then try to remember it with the hope that another problem similar to this will show up and then you solve it. So that is the logic that you have to use in mathematics. So you divide by cosine x, and on the right hand side, you also divide this by cosine x. First of all, I see it in the book. Even they don't concern about dividing by cosine, but if you're a good mathematician, you have to be worried about dividing by cosine. Why? If you have equalities, A and B, you can add 2 to both sides, you can multiply 2 by both sides, you can subtract a number. You can also divide by 2, but when you want to divide and keep equality the same, you have to be sure about something, that you are not dividing by 0, because dividing by 0 is forbidden. Yes? And I see in the book they are not concerned about that. They have to be concerned, because when I divide by cosine, it means that somehow I know cosine is not 0. But that is not possible for me right now because I don't know x. Yes? So if I don't know x, I don't know cosine. And if I am unlucky, it might happen that cosine turns out to be 0 at some point at least, and I will not be able to divide that. But so you need to explain why this is valid argument, why cosine is not 0 in this case. Why do you say, yes, cosine is not 0, so the book is lucky that you don't care about it and the answer is correct. But why do you think cosine is not 0? Yes?
Because cosine times another number is equal to sine of x.
So what is the contradiction? If cosine is 0, the right-hand side becomes 0, and then this means that sine should also be 0. So it means that x should be an angle for which sine and cosine are simultaneously 0. But this cannot happen, yes? Because sine is the y-coordinate, cosine is the x-coordinate. It is not possible to be on the unit circle and sine and x and y coordinates are simultaneously 0. Okay, so we are on the safe side to divide. Okay, that's one thing. But why this is useful? Because then what is the formula for sine over cosine? Tangent. So on the left-hand side, I will be left with just tangent. And on the right-hand side, I will be left with just a single number. And that is one of the standard equations that we know how to solve. Do you remember what was the formula for tangent? X was tangent inverse of square root of 3, but plus 180, not 360 degrees, yes? But this angle, this number should also look familiar to your eyes. Then you go to the formula sheet and then read it from the table. So it is 60 degrees. Yes? Okay. Let me solve another equation. We cannot solve any one of them right now. So let me give you this equation. So number 4. Let me see what can I change the form. So let me write it like this: 2 cosine x to the power of 2, and then plus 5 cosine x equals to minus 2. So we want to solve this equation. So I'm looking for an angle x, so that cosine of that angle to power 2 multiplied by 2 plus 5 times the cosine of that angle becomes minus 2. I want to find all possible angles x for which this is true. So all these examples that I gave you today are important. So if you have a notebook, I would recommend you to put a star on them. So these ideas you need to remember for the national exam. So when you page your book, you can immediately see the important points. So I don't expect you, by my teaching, you should be able to solve that one. unless you are very creative and you have a good background. But now this is part of my teaching, so next problem similar to this you should be able to solve it. Okay? Do you have any idea how to solve this problem? Yes?
Move -2 to the other side, and then we'll solve the essay second
Equation. Okay, so this is why I want you to teach yourself. The people who couldn't realize that, right now you need to send a message to your brain to say that, oh, why I couldn't. For example, if I give you this equation, could you solve it for me? How many of you can solve that equation? Okay, but that's exactly the point. This equation is the same equation in a disguised form. Okay, so the only difference is that cosine x, which is my unknown, is playing the role of this capital X. So if you want, you can say that let capital X be equal to cosine x. Yes? By the way, this is the method of auxiliary variable. So you bring a new variable in so that you can change the hard form of your problem to a simpler form. This is not necessary. You can solve this as a quadratic equation, but this will help you to understand the connection between these two problems. You need to teach your brain right now why you couldn't see the pattern. Yes, you could immediately see the pattern here, but you didn't realize this is the same problem in a little bit disguised form. Yes, so what you do, so you say that let cosine x be cosine x, then what happens for my equation? It becomes 2x squared plus 5x equals to -2. So you reduced your problem to a simpler problem in form, and then you solve it as you know. Okay, so for example, let me move this to the other side. Okay, and I prefer to use ABC formula, okay, because in PQ formula you have to divide by 2. In ABC formula I can start immediately. So my capital X is equal to minus b plus or minus the square root of this number to power 2, which is 25 minus 16, 4 times this times that. And then divided by 2 times this number, which is 4. And this formula is also given to you in the formula sheet, yes, ABC formula. And then you solve it. Okay, so what happens? It becomes minus 5 plus or minus, this number is 9, square root of 9 is 3. And then as usual here, you get 2 answers, but not for little x. For capital X. So minus 5 minus 3 divided by 4 is how much? Is minus 2. Or x is minus 5 plus 3 is minus 2 divided by 4 is minus a half. Yes? So what I did, I realized that this is the quadratic equation. This is a quadratic equation in capital X. This is a quadratic equation in cosine of little x. Yes? So I know how to do that. So I solved the problem, but I found my capital X. My goal is to find a little x. So then I have 2 problems to solve, yes? I would say number 1, x equals to what? Minus 2. Okay, how should I solve that? Instead of capital X, I put minus 2. So this means that cosine x is equal to minus 2. And what is the answer? So how many of you, so if you remember the formula for cosine was what? Plus or minus cosine inverse of minus 2 plus n times 360 degrees. Okay, so that was the formula for cosine. But how many of you agree with this? I'm not cheating about the formula. That is the correct formula. But I'm saying this is wrong. Why?
Cosine can be minus.
Yeah, cosine cannot go. I told you before. Cosine and sine are x and y coordinates of the points on the unit circle. Yes? So the maximum value for them is 1. The minimum value for them is minus 1. So cosine cannot go to minus 2. So no solutions. Since what? Minus 2 is less than minus 1. Okay? So this gives me an answer for capital X, but that capital X does not correspond to any little x. So no solutions from here. But there is another alternative. x can be minus a half. Yes? And then I have to solve the same equation, cosine x equals to capital X, but capital X is minus a half here. And now I know what to do here. So this is acceptable because minus a half is really between minus 1 and 1, so it's acceptable. X becomes plus or minus cosine inverse of minus a half, and then plus n times 360 degrees. And hopefully you remember that minus a half is also a famous angle, and the cosine of which angle is minus a half is 120, if you see that in that table. So x becomes plus or minus 120 degrees plus n times 360 degrees. N belongs to C. Okay. So the topic of trigonometric equations is very important topic, because don't think this is the only thing we talk about trigonometric equations. Later, whatever we learn in trigonometry, what new formulas we learn, new formulas will enable us to solve harder ones. So the topic of trigonometric equation is with you until the end of this chapter. So when we go to the next lesson, we learn more trigonometry. Using the new formulas we learn, we can solve harder trigonometric equations. So try to do some good practice on this. And if you have any questions, please let me know. Any ideas here? Any questions? I want to stop here. So next lesson will be talking about radians. So we will progress. But I think this is more or less what you need for being able to solve the problems in the book so far, and even in the national exam. Are you following these PDF files that I upload there? So there are some extra exercises. Try to do that, and if you have questions, come to me, okay? Any questions? Okay, thank you. So you can practice on your own now.